Your team made regionals, maybe won an award, maybe captained an alliance, and then you watched other teams move on to Worlds. You came home wondering exactly what the difference was. That is what this video is about. Not inspiration, not a list of things you already know you should do. A specific, honest breakdown of the gap, what it looks like, where it actually is, and what to do about it in the order that matters most. We are going to talk about fabrication, software, mechanism design, team process, and how to find the mentorship that accelerates all of it. Part 1 covers the first 3, Part 2 covers the rest. Let me start with something honest. The team in this video, Leviathan Robotics, Team 25667, a 7-member garage team out of Saratoga, is further along than most people realize. They are running Roadrunner for autonomous path following. They are using a SparkFun OTOS laser odometry sensor for localization, which is actually better hardware than deadwheel pods that most regional teams are still figuring out. They have a Limelight 3A mounted and running, using it to auto-aim their turret based on the robot's position on the field. They won the Inspire Award at a qualifier, which is the highest award in FTC. So the gap is not starting from scratch. The gap is specific, and specific gaps have specific fixes. Here is how I think about it across 6 dimensions: fabrication, CAD process, autonomous software, sensors, strategy, team process. On every one of these, the team is at a 5 to 7 out of 10. Worlds teams are at a 9. The gap is real, but it is not a chasm. It is a year of focused off-season work. The first dimension is fabrication. And I want to be specific here because there is a lot of bad advice about this. The team currently prints everything in PETG. They have a Bamboo X1C, which means they can switch to CF-PETG or CF-PA6 carbon fiber nylon right now, today, with no new equipment. That is the first move. Same printer, same slicer, dramatically stiffer result. Any structural bracket that currently flexes under load should be reprinted in carbon-filled material immediately. The next step is custom aluminum. And this does not require a machine shop or a CNC router. It requires a website called SendCutSend. You design a flat plate in Onshape, export a DXF file, upload it to SendCutSend, choose 6061 T6 aluminum at 1/8-inch thickness, pay about $35, and your parts arrive in 5 to 7 days. No equipment, no Makerspace membership, just a design and a credit card. Identify a PETG part that flexed or failed this season. Any part where you saw deflection under load. That is the first aluminum candidate. Design it flat, order it, learn the workflow. The second part you order will be better designed than the first. The second dimension, and the one with the highest return, is software. And this is where I have good news and a specific gap. The good news: Roadrunner is running, OTOS is running, Limelight is running. The infrastructure is there. The gap is that these systems are not fully connected to each other. Here is the specific problem. In Teleop, the driver uses robot-centric control. Push the stick forward, the robot goes whatever direction it is currently facing. But the robot already has the OTOS pose being computed every loop. Field-centric drive, where pushing forward always means field forward regardless of robot heading, is about 10 lines of code using that pose. And for a single driver managing 5 subsystems, field-centric is a completely different experience. The second specific gap is April tag relocalization in autonomous. The Limelight is mounted. The SDK has April tag support built in, but the autonomous does not use the Limelight to correct pose drift. After the robot drives to a scoring position, reading the April tag and correcting the pose estimate is the difference between autonomous that scores 80% of the time and autonomous that scores 95% of the time. The third gap in the code. The autonomous uses fixed sleep timers to wait for game pieces to feed through the mechanism. If the collection system is slow one match, the robot drives away before the elements are loaded, replacing those sleep calls with sensor-confirmed state transitions. Wait until the scoring mechanism reaches target speed, and a distance sensor confirms a game piece is present, makes the autonomous robust to any timing variation. The third dimension is mechanism design, and this one is about a workflow change more than a tool. Every FTC season, the same class of problem appears. Game pieces jam at collection. They get stuck at the transfer. The delivery mechanism does not cycle consistently. These are not random failures. They are geometry failures. The game piece's travel path through the mechanism has pinch points that could have been found in CAD before a single part was printed. The fix is not better simulation software. The fix is putting the game piece in CAD before printing anything. Model the game piece at exact dimensions in Onshape. Place it inside your mechanism assembly. Then drag it manually through the full travel path, from collection entry, through the transfer, into the delivery mechanism. Every position where the game piece cannot move freely is a jam point. You find this in 30 minutes in Onshape, or you find it in 3 matches at a qualifier. Design the handoff geometry first, as a sketch showing the game piece center path, and then build the mechanism around that path. Not the other way around. That is the first half of the gap. Fabrication, software, and mechanism design. Part 1 covered fabrication, software like field-centric drive and April tag relocalization, and mechanism design in CAD. Part 2 is about the less obvious gaps. Before team process, there's a gap easy to underestimate. The things your team doesn't know exist. Teams assumed servos maxed at 300 degrees. Not true. GoBuilda offers a 5-turn servo with 1800 degrees rotation. Same size, just $13 more. It was in the catalog, but the team never scrolled to that page. A missed opportunity. This is a universal pattern. Teams use what they know. Unfamiliar components aren't considered, leading to designs with unnecessary constraints. The fix: a dedicated catalog review. Once per off-season, read the full product catalog for each major vendor. Assign one vendor to one team member. Present what was new. A 3-hour investment changes what gets designed. Second, use AI as a design consultant. Describe a challenge to Claude or ChatGPT, asking what components exist. AI regularly surfaces options and approaches the team has never encountered. It expands the list of things worth investigating. Ask it, what sensors confirm game piece intake without stopping the robot? What mechanism approaches handle this scoring height with one motor? The answers will point you toward catalog pages you never opened and design patterns you never considered. The next dimension is team process. This one is the most uncomfortable to talk about. Right now, design decisions are driven by 1 or 2 members, whoever speaks first or with the most confidence. This is not a criticism, but a default behavior. Good ideas from quieter members get filtered out. The team converges on the first plausible idea, rather than the best available one. The loudest voice is not always the best idea. The fix is a 3-step process change. First, silent ideation. Everyone writes independently for 15 minutes. This dramatically increases the range of ideas. Second, the quietest member presents first. This changes who gets heard. Third, a Pew matrix. Evaluate all concepts against explicit weighted criteria before moving to CAD. Score each concept +1, 0, or -1. Multiply by weights. The highest score moves forward. And then a CAD gate. No part gets printed until the full mechanism assembly has been reviewed by the whole team. 2 more process changes. Scrimmages. 4 to 6 weeks before your first qualifier, contact local FTC teams. What a scrimmage reveals: how your autonomous interacts with a partner's, how your robot handles defense, driver decisions under pressure. And here is the secondary benefit. You see other robots and can ask the builder directly why they chose that component. Scrimmages are one of the best equipment discovery sessions available. Start building toward 2 robots. With 1 robot, practice stops when it breaks. With 2, there's always something to drive and build. It forces a second driver. It lets the mechanical team iterate on Robot B, while Robot A stays match ready. Here's the thing about all these methods: they are excellent. And they will never happen without explicit assignment. At every team session, some members are on the robot, some are waiting. That waiting time is currently lost. It should be structured. Every team member has a defined task at every session, either on the robot or on the knowledge board. Assign a catalog reviewer, a CAD studier, an AI consultant, a community monitor. 5 minutes at the start to state assignments. 5 minutes at the end to share what was found. The information compounds. The team's knowledge grows faster. The final dimension is mentorship. A garage team can close a significant gap without spending money on hardware. Find technical mentors through top local FTC teams, FRC teams, the FTC Discord, or college students. If an Apple employee joins as lead mentor, a $325 annual grant through Apple's first partnership unlocks automatically. What a technical mentor provides is not just knowledge, it is a second design review. Someone who has seen a similar mechanism fail and can tell you in 5 minutes why the geometry is wrong. That saves weeks. Here is the off-season roadmap, in order of impact. 1. Implement field-centric drive, 10 lines, do it this week. 2. Add April tag relocalization to the autonomous. The Limelight is mounted. 3. Get your first send order in. Identify a PETG part that flexed or failed. Design it as a flat aluminum plate. 4. Design the full next season robot concept in Onshape as a complete assembly before printing anything. This is the single biggest process change the team can make. 5. Add a co-driver. Gamepad 2 is already stubbed in the code. 6. Reach out to local FTC mentor contacts. Post your ask in the FTC Discord. Contact FRC teams, college robotics clubs. 7. Do a full vendor catalog review before next season starts. Assign 1 vendor per person. Present what was new. 8. Schedule a scrimmage with local teams before your first qualifier. Start the outreach in September. 9. Start building toward a second robot, even a practice chassis. It forces a second driver and keeps everyone building. Here's the bottom line. Team 256667 has better infrastructure than most teams at their stage. Roadrunner, OTOS, Limelight, Inspire Award. These are not small things. The gap to Worlds is not a hardware gap or a talent gap. It is a process gap. Full KD before building, connected systems, structured ideation, equipment discovery, scrimmages, drive team practice, a second technical voice. The teams at Worlds are not dramatically more talented. They are more systematic. They find problems in CAD instead of on the field. They practice 100 cycles before their first qualifier. They have someone who has seen the mechanism fail before and knows why. That is achievable. And this off-season is when it happens. Full report and links at robotics.signite.com.